Okay, so normally I would have more lemons for this, but we'll make do. Okay. And normally I would also have all of these on a plate for a citrate citrus plate. Okay? Just gonna draw one right here. Okay. That's a plate. Okay. Okay, so one of the main points of glycolysis is to make acid coal, which will be used in the citric acid cycle, okay? So let's do this the boring way first. Okay, so the boring way is citrate, 6 carbons, converted to isocitrate, 6 carbons, converted to alpha-ketoglutarate, 6 carbons, converted into succinyl-CoA. Alpha-ketoglutarate, 5 carbons. Sorry, guys. Converted into succinyl-CoA, 4 carbons. Then succinate, fumarate, malate, oxaloacetate. 2 more carbons come in from acid coal, and we're back to citrate. Okay? Then go around again. Citrate, isocitrate, alpha-ketoglutarate, succinyl-CoA, succinate, fumarate, malate, oxaloacetate. Okay? And the point of this is to produce NADH and FADH. That's the main point in terms of producing electron carriers for oxidative phosphorylation. Okay. Okay. So how do we remember these steps? I like to think about it as a Japanese game show in which they're having a contest to see who can eat the spiciest or most acidiest food. So I like to think about it as the octagon of acidy food tasting. Anyway, so it's called, what they do is they start out with a citrus plate, okay? Have you guys seen mixed martial arts, UFC? So that's where the octagon part of it came from, because it's 8 steps that you need to know. Anyway, we start out with a citrus plate, okay, for citrate. Then the next step is the contestant, so that'll be me, gets to isolate one of the citrates that I'm not going to have to eat, okay? So isocitrate, that's the first thing that happens. And then after that, the alpha key for the host of the show, the alpha, also gets to pick one that's not going to be, those are off limits. Those can't be used. So went from citrate, citrus plate, to isocitrate, to alpha-ketoglutarate. Now the next step is I'm actually going to have to get one of these, and the first thing would be succinyl-CoA. Just going to have to suck on it. Succinyl for just sucking. Nothing happens, right? But then the next step is I'll have to succinate, suck and eat. At which point, and I have some fumes coming out of my ears, right? So they're like the cartoon fumes. And I'm going to say, that was mal, which mal in French is bad. That was, mal. Woo. And then, because it's a game show, there's going to be a fan of white who resets everything for the next round, except in this scenario, it's an ox dressed up as Fana White. Now that makes sense if you remember the previous information from pyruvate and the previous information from glyceraldehyde 3-phosphate being the bad shoulder angel with the horns, right? Gets converted into pyruvate, which can escape and impersonate oxaloacetate, the ox Fana White, right? So I'm just trying to connect all that. That's why all that stuff works, is because that bad shoulder angel with horns can escape, impersonate the ox, and then escape back up for gluconeogenesis. Okay. Okay. So let's do another round, because they always do multiple rounds on these. Okay. So start out with citrate, citrus plate, right? Next is isocitrate. Pick out this one. Next is alpha ketoglutarate. This out. After that, gonna just suck sinyl-CoA. Nothing. And then I'm gonna suck and eat. Got the fumes. The fumes. Muh. And I say, Mo, that was bad. And then the ox Vanna White resets the cycle. Okay? Okay?
You're so dedicated to this.
Yeah.
R.I.P. your teeth.
Okay. So, okay. And now, so the whole point of that is to produce NADH, which is an electron carrier. Okay? So if you guys had to think about a small critter that was an electron carrier, what's the first thing that comes to your mind? Fair. Not what I was. Pikachu, yeah. But for copyright reasons, and also for mnemonic reasons, we're going to use NADH for instead of a naked mole rat, it's an electric naked mole hamster. Okay? So this is my naked mole hamster right here. Let me see if I have another drawing of that. I don't. Okay. So this naked mole hamster, NADH, is an electron carrier. Okay? It has two sides, NAD plus and NADH. Okay? There's a reduced form and there's an oxidized form. The form that has an electron that can donate that electron, and one that is lacking an electron that can accept an electron. And it's really easy to mix up which and which. So this is how I remember it. So the electric hamster here, whenever he gets insulted or reduced, that gets him all charged up, okay? He gets all charged up, and then there's electricity in between his two ears, which looks like an H. So NAD plus is reduced to NADH, at which point the electric hamster has a bunch of electricity built up, so it has an electron that it can donate, okay? So it's a reducing agent. So let's say somebody said to the NAD plus, okay, starting over, the NAD plus, so it says, you suck, naked hamster thing. And then it gets, so that was reducing to the hamster. It gets real angry about that and builds up charge in between its ears. At which point, now it has the ability to blast something with electricity. So it can be like, no, you suck, and donate that electron, okay? Okay, so does that make sense? NAD plus is reduced to NADH. So NADH is the reduced form, meaning it can act as a reducing agent, okay? Okay, hopefully that makes sense. Okay, so the whole point of building up NADH is to use it in the electron transport chain, which I like to think about. Have you ever heard of the game Hungry Hungry Hippos? Okay, so instead of that, this is going to be Hungry Hungry Hamsters, okay? So, so there are 5 complexes in the electron transport chain, but it's kind of like there's 4 plus 1 odd one, okay? So just like in Hungry Hungry Hippos, in our Hungry Hungry Hamsters game, the hippos all face the inside of the table, right? Just like how the hippos here all face the most inner part of the mitochondria. Does that make sense? So you would automatically know where this is happening, right? And when the game starts, there's a bunch of balls in the center. Just like these protons, which are like these hydrogens, which are just one proton, so they're just one ball, okay? Game starts, and there's a bunch of proton balls in the middle. Now, let's say you electrocuted the game board, and all of the hamsters start gobbling. They gobble up those hydrogens and poop them out on the other side, right? Building up a proton gradient, which will then be used by ATP synthase to make ATP. And I'll explain my drawing for that in a minute. Okay? So there's 4 complexes here. Do you guys need to know the poisons that affect the... Okay, good. Okay, so the poisons that affect the electron transport chain are all mouse-related, fortunately. Using the mnemonic RACO for raccoon, okay? We're dealing with rodents. Okay, so complex 1 is inhibited by rodinone for rodent, rodent be gone, or rodent 1, rodinone. See there's a 1 at the end of rodinone? So that inhibits complex 1, okay? Then there's anti-mycin for N3 mycin inhibits complex 3. Complex 2 is succinate dehydrogenase. It sucks so much that it doesn't even have a poison that works on it. It's also why I drew it tiny here, okay? And it doesn't span that membrane. Anyway, rodinone for rodent 1, and anti-mycin for N3 mycin, anti-mice. Then there's carbon monoxide, which is used to euthanize lab rats, and cyanide, which is used in rat poison, okay? And then the last one is oligomycin for a few, oligo for a few mice. It hits ATP synthase, meaning that the whole thing is going to be backed up. So it inhibits kind of the whole thing, okay? Does that make sense? Okay, so citric acid cycle builds up NADH, okay? So NAD plus is reduced to NADH. So the naked mole hamster gets real angry after being insulted, gets electricity between its ears, which looks like the H. That angry naked mole hamster then goes and electrocutes these water-type hungry hippos, or hungry hamsters, okay? Blasts them. The electricity from that causes them to all start gobbling. They grab the hydrogens that are on the most inner part of the mitochondria and poop them out into the intermembrane space. That concentration gradient is used to power ATP synthase. Poisons that inhibit this: rodinone, anti-mycin, carbon monoxide, cyanide, and oligomycin. If you spell all those out in order, you get RACO for raccoon. Okay? Any questions? Okay, we can go ahead and do another section.